All right, guys, these are your notes for section 7.1. So I'm going to write the title at the top here, 7.1, which is classifying, adding, and subtracting polynomials. Okay, so there's the title for this section here. And I have already written down some of the definitions here, so that doesn't take a whole lot of time on the video, but we're going to talk through them. So the first definition we have here is a polynomial. And a polynomial is an expression consisting of many terms. Okay, so in our last unit we talked about the definition of a monomial, right? We had a monomial, and this was just a number, a variable, or a product of a number and variable. So just a reminder there, you don't have to write this down, but we worked with monomials. So a monomial, we had just a number, or maybe we had a variable, or we had both, a number times a variable, which we call that number the coefficient of that variable. Now we're going to look at polynomials, where we have several of these, or we can have more than one of these, and they're multi-term. So a monomial, so one monomial we consider to be one term. Okay, and then when we start adding and subtracting these terms together, that's when we get a polynomial. So here are some examples in the different colors of polynomials. So the first one we have is just 5, which we consider a monomial, but all monomials are also polynomials. Okay, negative 6x is a polynomial. Here we have, so those are each one term. Here we have two terms, 4x squared minus 1. So there's two terms here. We have 4x squared, and then we have a negative 1. There's two terms here, but since we are combining them by subtracting the 1 from the 4x, we consider that to be a polynomial. This has two terms. This is a two-term polynomial. Okay, in this last one here, we have a bunch of terms, 9x cubed plus 4x squared minus x minus 2. That is also considered a polynomial because we have 4 terms here that are being added and subtracted together. So we have 4 different monomials here pushed together with either addition or subtraction signs. Okay. If you have some numbers that are being multiplied or divided together, those are considered to be the same term. So multiplication and division between different numbers, those are considered to be one term. But if you're separating them with addition and subtraction, those are multi-terms, and we call them polynomials. Okay, and then let's look at something we call standard form, which is how we always like to write our polynomials. And these must be written in alphabetical order. Okay, so if you have variables with a's and b's and x's, you have to write them in alphabetical order with the highest exponent first. So the highest exponent on the A would go first, and then the next highest exponent on the A would go second. And then if you have a B, then after all, you list all of your A's, then you write your B with the highest exponent, and so on. Okay, so let's do a little bit of practice here. This one says, write each polynomial in standard form. Okay, so looking at number 1, we only have one variable here. We have x, and so then we don't need to worry about the alphabetical order, but we do need to worry about writing the highest exponent first. So the highest exponent on x is going to be this 2, and then the next highest is going to be the 1 here that is not written in, and then we'll write the constant last. So in standard form, this is going to look like 2x squared plus 3x plus 1. And when we're rearranging these terms, it is really important to make sure the signs stay with the same term, okay? So these here are all positive, so they're going to be all positive in the answer. But if one of them was negative, we would keep that subtraction, that negative, with that term. Okay, so let's look at number 2. Only one variable here, so we don't need to worry about the alphabetical, but we will need to write them right with the highest exponent first. So we have a positive 7k here, 7k cubed, so we have 7k cubed. Then we have a positive k squared, so plus k squared. We have a negative k, so it's going to be minus k, and then positive 64 plus 64. And that's it. That's written in standard form for you there. Number 3, highest term would be the w cubed plus 5w squared minus w plus 28. So we're just rearranging all of these to have the highest exponents first. Here we have a negative n cubed. This will be first, so we're going to write negative n cubed first. There's no n squared, so we go to the next highest exponent. That is n, and then plus 24. Okay, 2 more here. So here we have a mix in variables. Okay, so we have the a's and the b's. So we're going to look at writing the a's first. Okay, so we look for the a with the highest exponent, which is this a cubed, so we'll write this first, a cubed, and then the a with the second high exponent, which is this a squared. Even though there's a b squared here, that's fine. We're after the next highest exponent on the a, which happens to be the same term. So we're going to add 5a squared, b squared. Okay, so we got those two, and then the next highest exponent on the a is this a with the 1 here. So then we're going to add 2ab, and then our last one, we don't have any more a terms, so then we go to the next letter in the alphabet, which there's only one more variable, is this is this b, and the highest exponent on that is the cubed, so we'll subtract 2b cubed. Okay, so there's an example of where it's mixed a little bit. Okay, and our last one here, we have 2 variables as well. C comes before D, so we'll look for C with the highest exponent, which is the C cubed. It is being subtracted, so we're going to write negative C cubed, and then this term with the C squared, minus 7C squared D squared. Okay, no more C's, so we'll move on to D's. We have this plus 5D cubed, and then this 13. Plus 13 here. So just remember, wherever we have subtraction symbols, we want to keep that with the term that follows. So we had a minus c cubed, we put the negative up there, and then we had this minus 7c squared d squared, and we kept the minus up there too. Okay, so there is your standard form for more than one type of variable. Alright, and the last thing we're going to look at in this video is the classifying polynomials. Okay, so polynomials are classified by their degree and their number of terms. So let's look at what the degree is first. I forgot to write this in first. So the degree of an exponent, the degree of a polynomial is going to be the highest exponent. Okay, so let's take a look at some of these example problems we did. The highest exponent in number 5 here is a 3. So this polynomial has a degree of 3. Okay, the highest exponent in number 1 is a 2, right? So the degree of this polynomial is 2. So that's what we mean when we talk about degree. So if we classify a polynomial by degree, we have these first 5 options here, and it does keep on going, but in this class we probably won't look at any polynomials with a degree higher than 4 anyway, so let's just talk about classifying these guys. So if the highest exponent, or the degree, is 0, we say that this is constant. Okay, and when we have, if you remember from our exponent rules, if we have an exponent on anything of 0, that is equal to 1, right? So if we have a degree of 0, that means that our variable actually isn't even being written because it's equal to 1. So if we had something like 6x to the 0, that is the same thing as 6 times 1, which is equal to 6. So the degree of this is 0, and we call it a constant polynomial. Okay? If we have a linear degree, if we have a degree of 1, we call that linear. So if we had an x to the 1, we simply write that as x. So if we had something like 6x to the 1, we just write that as 6x. So there's no exponent being written, and it's just assumed to be 1. We call these linear polynomials. And then if we look at a degree of 2, just like in our example problem number 1, x squared, if this is the highest one, we call this quadratic. If our degree is 3, x cubed, we call that a cubic. And then if our degree is 4, x to the 4th, we call that a quartic polynomial. Okay, so that's how we can classify polynomials by degree, but we can also classify polynomials by the number of terms that they have. So we talked about what constitutes a different term, so basically the number of monomials that are being added and subtracted together, right? So if we just have one term, we call it a monomial, which is what we were working with in our last section, just one number that maybe has numbers and variables being multiplied, or maybe it's just a number, maybe it's just a variable, but only one term, we call it a monomial. Okay, if we have two terms, like x plus a, that would be a binomial. So if we say a times x, that's a monomial. X plus a, that's a binomial. Okay, if we had a trinomial, we could have something like x squared plus x plus a. Okay, these aren't the only type of trinomials. We could have something like x to the 4th plus x plus a. So it doesn't really matter the degree, as long as there's just 3 terms there. That's what constitutes a trinomial, just 3 terms. And then a polynomial is anything that has 4 or more terms. Okay, so if we look at these first examples up here, we would say that this first one here, this 5, is a monomial, right? Just one term. This negative 6x is also a monomial, just one term. This 4x squared minus 1 is a binomial. There's 2 terms here. Okay, and this last one here, this 9x cubed plus 4x squared minus x minus 2, there's 4 terms here, and we call this a polynomial. Okay, if there were more terms being added, we would still call it a polynomial. So if there's 4, 5, 6, or anything greater, we just consider all of those polynomials. Okay, so let's look at the example problems for classifying these polynomials. So the directions say to classify each polynomial by degree and number of terms. So each of these will have 2 names attached to them. So first, let's look at number 7. We have just the number 6. Okay, so we can say that this is equal to 6 times 1, right? Which we could also say is equal to 6 times x to the 0, right? Because we worked this backwards last time. X to the 0 is equal to 1, and you know, any number times 1 is just equal to that number. So if we don't have a variable showing up, then it is assumed that the degree is 0 and that it's just equal to 1, and that's why it's not being written. Okay, so if we classify this by degree, we'll say that this is constant. Okay, and then we ask ourselves, how many terms do we have here? Well, there's only one term, just 6. There's nothing being added or subtracted. So we're going to say this is a constant, and it's a monomial. Okay, looking at number 8, we have a variable here. There's no exponent written, so that means the exponent is assumed to be 1. And if we look at a degree of 1, that means it's going to be linear. So we're going to say that this is linear. And there's only one term. It is negative, but it's not being added or subtracted to anything. So that means that it's just one term. It's going to be a monomial. All right, if we look at number 9, we have a variable p. There's no exponent written on it, which means that it is just 1. So this is also going to be linear. The highest exponent is 1. It's going to be linear. There's 2 terms. There's 7p, and there's a positive 1. So 2 terms will be, if we look at our list over here, a binomial. So it's linear, and it's a binomial. Binomial. All right, number 10, we have 2 variables here. One has a 2 for an exponent, one has a 1 for an exponent. The highest one is 2, which is our degree. So if we have a degree of 2, this is a quadratic polynomial. Quadratic. Okay, and look at the number of terms. We have 3 terms here, so it's a trinomial. All right, number 11, we have 1 variable with an exponent of 3. The degree is 3, so this is cubic. There are 2 terms here, so it's a binomial. And then number 12 here, so we have an m to the 4th, an m squared, and m. The highest degree is 4. The highest exponent is 4, which means our degree is 4, and according to our list, if our degree is 4, then this is a quartic. And there are 4 terms here, so it's a polynomial. And there is your classifying and standard form polynomials.